Today we're talking about neural networks. Think of them like teams of tiny decision makers called neurons. They pass signals to each other to help computers spot patterns in data. Join me for this short video designed to simplify a very complex topic. A neural network is a bit like a team of simple decision makers, which we call neurons. Each neuron looks at its inputs and decides whether to pass on a signal, kind of like teammates passing a ball. As these signals move from one neuron to the next, they build up to a final decision, like classifying an image or making a prediction. By working together this way, the network can learn to recognize patterns in data, just as our brains learn to spot shapes, voices, or faces. In this picture, you can see how real neurons connect. In a neural network, we recreate that idea with mathematical links instead of biology. Imagine you have to sort soccer balls by size and color. One person checks size, another checks color, then together you decide which bin. That's how neural networks sort information step by step. Each neuron gets inputs, multiplies them by weights to show what's important, adds them up with a bias, and uses an activation rule to decide if it fires. This firing sends a signal onward. Neural networks are organized in layers. The input layer gets your data, hidden layers do most of the work, and the output layer gives the final answer, like yes or no. If there's just one hidden layer, the network is shallow and handles basic tasks. Add more hidden layers, and you get a deep network that can tackle harder problems like recognizing faces. Training is like practice tests. You show the network examples with answers, it guesses, sees if it's wrong, and tweaks its weights. After thousands of rounds, it learns to make great predictions. Think about studying for a math test. You try problems, get feedback, and improve over time. Neural networks learn the same way by practicing over and over. Neural networks are everywhere around us. In self-driving cars, they help the vehicle see pedestrians and stay in its lane, just like how our brain processes what our eyes see. In voice assistants, they turn your spoken words into text and meaning, so you can ask questions naturally. In medicine, they can spot patterns in medical images or lab results that might be too subtle for the human eye, helping doctors catch diseases earlier. And beyond these examples, neural networks tackle problems that simple step-by-step rules just can't solve, like translating languages instantly or recommending songs you're likely to love. That's why learning about neural networks isn't just theory. It's the foundation behind many of today's coolest and most useful technologies. Thanks for joining this introduction to neural networks. We've covered how neural networks work, how layers build understanding, and why these models power technologies from self-driving cars to medical tools. Be bold and explore new tools. Work with others to improve your understanding and contribute to this technology. If you'd like to learn more about AI, watch videos, dive into blogs, or explore case studies, head to amedicinupdate.com or apublichealthupdate.com. Keep exploring and learning.